Greetings, space and life enthusiasts. For centuries, humanity has asked itself, are we alone in the universe? Today, we embark on a journey to explore 3 planets that scientists believe have the greatest potential for life to arise. Prepare to explore distant worlds where, perhaps, the heart of life already beats. Let us start our journey with a rather unusual candidate for potentially habitable worlds, Titan, Saturn's largest satellite. Titan is a true space giant, bigger even than the planet Mercury. And most strikingly, it is the only satellite in our solar system that has a dense, thick atmosphere. Look closely at these images, see that orange mist? Titan's atmosphere is 1.5 times denser than Earth's and consists mostly of nitrogen and methane. Because of this dense blanket, the temperature on Titan's surface is extremely low, about 179 degrees Celsius. The water here is frozen into rock, forming a hard ice shell. What kind of life could there be here? A frozen, bleak world where warmth and liquid water have no place. But don't jump to conclusions. Titan is interesting because on its surface are splashing seas, lakes and rivers of liquid hydrocarbons, methane and ethane. Imagine the landscape. Endless methane lakes surrounded by icy cliffs and rivers slowly flowing to the sea. It sounds like science fiction, but this is the reality of Titan. Scientists speculate that in these exotic environments, completely different from Earth's, there may be life based not on water but on methane. This would turn our understanding of how life can originate and evolve in the universe upside down. After all, on Earth, water is the basis of all life, but Titan shows that alternatives using other chemical elements and solvents are possible. This opens up incredible prospects for finding life in the most unexpected places. It is very difficult to imagine what methane life might look like. Perhaps they are microscopic organisms floating in the depths of methane lakes. Perhaps they are more complex creatures that use hydrocarbons as an energy source and secrete other chemical compounds. Of course, these are just bold guesses based on our knowledge of chemistry and biology. But Titan is a unique laboratory where we can explore the possibility of life in a very different environment, challenging our ideas of what is needed for it to arise. Perhaps one day we will send a research vehicle to Titan that can dive into methane seas and look for signs of life. That would be one of the most exciting discoveries in human history. Until then, we can only hypothesize and marvel at this mysterious and beautiful world. Now let us move beyond our solar system to our nearest stellar neighbor, Proxima Centauri, a red dwarf star just 4 light-years away. Around Proxima Centauri orbits Proxima Centauri b, an exoplanet comparable in size to Earth, and most intriguingly, located in the so-called habitable zone of this star. The habitable zone is the area around the star where the temperature allows liquid water to exist on the planet's surface. And the presence of liquid water, as we know, is one of the key ingredients for life. So could there theoretically be an ocean on Proxima Centauri b? Could there be waves splashing under the red light of a distant star? However, it is not that simple. Proxima Centauri is a red dwarf, much smaller and colder than our Sun. This means that Proxima Centauri b receives much less light and heat than the Earth. And what is more, Proxima Centauri is notorious for its powerful stellar flares, sudden bursts of energy that can be extremely dangerous to any life on the planet's surface. Imagine being constantly bombarded with powerful doses of radiation on Earth. Few people could survive that. But despite these difficulties, some scientists believe that life on Proxima Centauri b is still possible. If the planet has a dense enough atmosphere, it could protect the surface from radiation and retain heat. Or perhaps life hides beneath a thick layer of ice, similar to what is suspected on some satellites in our solar system. It is quite possible that complex multicellular organisms such as plants or animals may not be found on Proxima Centauri b, but life in the form of microorganisms, bacteria or archaebacteria, may well have adapted to the harsh conditions of this planet. They could survive by obtaining energy from chemical sources such as hydrogen sulfide or methane, just as some microorganisms do in the depths of Earth's oceans near geothermal vents. Perhaps in the future, we can send a probe to Proxima Centauri b that will study the planet's atmosphere and even try to take soil samples. Only then will we be able to say with certainty whether or not there is life there. But even now, Proxima Centauri b remains one of the most interesting and promising candidates for the role of second Earth in the universe. Finally, we are approaching our last candidate for habitability, TRAPPIST-1e. This planet is one of 7 orbiting an ultra-cold red dwarf called TRAPPIST-1. Imagine that. 7 planets tightly clustered around one small star, like pearls on the string of a cosmic necklace. TRAPPIST-1 is only 40 light-years away, which is not very far by cosmic standards. And of all these 7 planets, it is TRAPPIST-1e that is most similar to our Earth in size, mass and density. It is also in TRAPPIST-1's habitable zone, which means that liquid water, a key ingredient for life as we know it, could theoretically exist on the surface of TRAPPIST-1e. TRAPPIST-1e probably has a rocky structure, like Earth and Mars, and contains a significant amount of water. Scientists speculate that this planet may have oceans full of life. Of course, life on TRAPPIST-1e is likely very different from life on Earth. TRAPPIST-1 is a red dwarf that emits far less light and heat than our Sun. And because of its proximity to its star, TRAPPIST-1e is likely in a tidal lock. This means that one side of the planet is always turned towards the star and the other side is always away from it, just as the moon is only turned towards the Earth with one side. This creates a huge difference in temperature between the day and night sides of the planet. But even in such extreme conditions, life can exist, especially in areas where temperatures are more moderate, such as near the terminator, the line separating day and night. What could TRAPPIST-1e be living in the oceans? Perhaps they are simple microorganisms adapted to reddish light and tidal capture. Perhaps they are more complex creatures using chemical energy sources, as some deep-sea organisms on Earth do. Or maybe there is intelligent life out there, having built a civilization on the ocean shore under the rays of a distant, red star. Unfortunately, we can't yet see the surface of TRAPPIST-1e in detail, but future missions, such as the James Webb Space Telescope, will be able to study this planet's atmosphere and try to detect signs of life, chemical compounds that can form naturally.